how BigBasket uses Kubernetes to handle unpredictable traffic surges while optimizing the cost. So give it a round of applause for Sushant Gulati.
Hey, hi, welcome everyone. My name is Sushant and I lead the DevOps and platform engineering teams at BigBasket. Today I want to share our journey that I think will resonate with a lot of you who run platforms at scale. I want to show you how we built a system to handle unpredictable traffic. And I think the dilemma that we've always faced is should we run over committed and should we run extra provisioning? But I want to run you through our journey and help you get started. So before I talk about our infrastructure, I just wanted to set the context. So we at BigBasket are not just any other e-commerce company. We run with a very tight 10-minute SLA. We deliver lakhs of orders across 600 cities throughout the day. And what it means for us is that our backend cannot tolerate any scaling delays. We cannot afford to have any issues in terms of cold starts, pod scaling, etc. So anything which is running on our systems, for example, our 150 microservices running on multiple clusters, they are very tightly coupled. So any issue cascades downscale. So when I say infrastructure is a product for us, I literally mean it. And this is the context with which we take every engineering decision at BigBasket. So the reality of our traffic, right? The traffic pattern is predictable only to a certain extent. We have two peaks during the day, morning and evening when people order the groceries the most. But beyond that, there are a lot of other things. Our marketing teams run flash sales. There are events, festivals, IPL, Diwali, Valentine's Day. All these attribute to a lot of unpredictable scaling. Then there is also marketing flash sales, etc., which are given to us probably in notice of hours, and we have to scale and ensure that things are working fine. So we were always faced with a very tough choice. Should we over provision to be safe, or should we keep a lean thing and then take the risk of having issues in cold starts, etc. But I think we needed a better option, so we tried out Cast, and that's what I want to talk about today. It wasn't that we were doing nothing before Cast, right? So we had basic autoscaling. We also had cluster-wide cost visibility, and we also were maintaining our systems against spot interruptions. So we had the basic tooling in place, but we had significant gaps as well. What we were lacking was efficient bin packing. So what happens is when you do not have efficient bin packing, your number of nodes go high because your capacity goes underutilized. You also have workloads which are not matched to the nodes provision. So the wastage happens on that level as well. We also were not having any proactive node autoscaling, because of which, or spot interruption handling, because of which anytime the interruption happened, we only had those 2 minutes that AWS provides us. And the only way we could save ourselves was over provisioning, and that adds to a lot of cost at our scale. Now, when we were evaluating the solutions, our criteria were very deliberate. We did not want to compromise on reliability. So bin packing with intelligence was something that we really wanted to. We also wanted to have workload-aware node provisioning. Proactive spot interruption handling was something that we could not live without. But the other things were also there. We also had optional requirements where granular cost visibility was required. We also wanted to have rebalancing capability so that we could run our patching and other things through the tooling, right? And Spot provided us with a lot of features out of the box. We had intelligent workload autoscaling plus the security scanning that was provided to us, and we also had intelligence bin packing. So we were able to save a lot of things, which I think I'll show in the next slides. But I think the major thing that we found with Cast was that it's the only platform that we found which was able to give us a good reliability compared to the cost benefits as well. we onboarded with Cast a couple of years back, and I think the first thing that we onboarded was Note Autoscaler. If you see the numbers, the reduction in cores and the daily cost reduction are significant. And we had 32% reduction in CPU cores and 47% in daily cost reduction. And there were a few things that worked for us, right? So, what kind of nodes are provisioned for CPU intensive or memory intensive workloads? What kind of bin packing happens so that the nodes, when they are provisioned, are already tightly packed, but the workloads are also packed on top of them. And we had some custom decisions that we had to take for Cast to run efficiently on our environment. We could not handle any delay in terms of 2 or 3 minutes of new node provisioning. So we are always running headroom pods. Now these are like low priority pods that keep on running on our nodes. As soon as a new spike comes in, these pods get replaced by our workload pods, and the startup time is quite fast. We also decided deliberately to exclude crons and batch jobs from the node autoscaler, because the signals for autoscaling, which the machine learning algorithm picks up, they are polluted because of this. And we also did auto rebalancing at off-peak hours. What that does is it keeps on packing even more efficiently because of the holes left when the pods get decommissioned. So that's something that we have seen added a lot of value when we do active rebalancing at the night. And we are also starting to work on an advanced feature, which is workload autoscaling. This is something where all of you would have noticed who work on infrastructure that the development teams tend to over provision their environment. The requests for memory and CPU are quite high, right? This is understandable because they don't want to take a risk, but this safety buffer over a period of time accumulates into something which can lead to a level of wastage. Now, when we started looking at it, we realized that our developers were quite conservative about these things, and they wanted to make sure that their systems run fine. And when we discussed with Cast, we found that they've come out with a solution that can help us exactly with that. Running continuous optimization with the teams is not possible. We have 20 plus engineering teams, 300 plus developers. Explaining things to them, getting them to do rebalancing every time is very difficult, right? So we needed an automated solution. But what we did was this time we tried to do it in a very deliberate, data-driven manner. We enabled workload autoscaling on non-prod. And then based on that, we tried to monitor and tune the numbers and metrics that were coming out. We found that if we were able to tune the things better, we could achieve like 40% of savings overall. And if you see, this is something that is very clearly shown on the charts, right? So what we have tried to do is we've presented these results to the management. They are very happy because they know that we have delivered it. And then we have started rolling it out on production in a very gradual manner. But because it is production, we have very strict criteria that we want to maintain our P99 latencies, which we should not get impacted. We also have a criteria that it should maintain between 20 to 40%, because we have achieved 40% in non-prod. At least we hope that 40% would be something that we'll achieve in production as well. And we should not have any autoscaling related incidents which lead to any outages or any delays in loading the pods, right? So let me put some numbers on the table. Over a period of time with Cast, we've tried to optimize our environment, and the numbers speak for themselves. We've achieved like 29% overall cost reduction. I already showed you a slide where it was 47% of daily cost reduction. And then we achieved 40% of reduction recently in non-prod when we tried out the workload optimizer. But I think we should not just focus on the cost reduction that we have seen. We should also look at what reliability has been brought in while these kind of optimizations are happening. There are a lot of possibilities when you do this open source. But the problem is that if you do that, you do not always have the confidence of reliability. And I think what we've seen over the time is that we don't have any we don't have any cold start spikes related. We don't have any proactive. We have any. Sorry. Excuse me. Slide. Yeah, sorry. So we have not noticed any cold start related delays during traffic spikes. We have not seen any proactive rebalancing related problems. So our spot interruptions are handled very well. And we've also seen that during the active rebalancing happening during the night, there's a lot of entropy that builds up in the system. There's a lot of waste that still accumulates that gets taken out. So I would say that I would leave you with a few lessons that we learned while adopting Cast. We did not take a very rushed approach. We took a very careful and cautious approach. We did a phased rollout across all our environments. That's something that I would suggest to anyone who's trying out any new software, right? We also found that headroom pods are a lifesaver when you have to handle sudden spikes. That is something that autoscalers can try to provide, but this is something that is really helpful. We've also seen in our cost analysis and FinOps discussions that instance types which are fitted to our workloads matter a lot more than the price-based discussions that regular autoscalers do. And we should also think about excluding what we don't want on the autoscalers, right? So batch jobs, cron jobs, which do not have the capability to be bin packed more, add a lot of noise to the autoscaling signal, and they do not get handled well. So we've excluded them. And then rebalancing is an ongoing discipline. So if you want to manually do it, it will never happen. You have to offload it to some system like this, and then it can lead you to have a very well-balanced system. Yeah, so we are not done fully yet. We are in the middle of our rollout for production. We are doing an workload autoscaler rollout, which is running really well in non-prod, but we are rolling it out to production. We have like 40% done, and I think this week we'll be fully there, and we hope to achieve the same level of savings that we had in non-prod. And forward-looking projects are like we want to integrate it with our CI/CD pipeline so that developers know what is the cost of their deployment before they even merge the PRs at their level. We also have enabled granular cost reporting that teams can get for their own workloads, so they know exactly how much is the cost. And then we also are planning to move to multi-cluster environment where we can handle a scale well. So this solution should also handle multi-cluster environment. Right? So I think that was all from my side. Thank you so much. If you have any questions, I'll be happy to take them, and I'll be available outside as well.